Hi everyone. In this video I am going to demonstrate how to obtain robust standard errors and test statistics when performing linear regression using Stata. And in particular we are going to be focusing in on the use of heteroskedasticity-consistent standard errors when testing inferences concerning population parameters. So the reason why this topic is important is that when you're performing linear regression, one of the key assumptions is that of homoskedasticity, or basically the constant variance of the residuals across levels of your predictor variables. And so when you have a violation of that assumption, it can lead to biases with respect to your standard errors and ultimately impact the inferences that you make regarding population parameters. So with heteroskedasticity consistent standard errors, the idea is to eliminate or at least reduce any biases that may be present as a result of heteroskedasticity in your residuals. Now before we get started, I want to mention that underneath the video description I am going to include a link to the data file that I'm using in this presentation so you can download the data to follow along. And additionally, I'm going to include a link to an article by Hayes and Kai from 2007 which discusses the use of these types of standard errors as a way of dealing with the problem of heteroskedasticity. So if you go to the Springer website, which is located right here, then go to the download PDF. You can download a copy of the article and read more on the topic. So once again, I will include this link underneath the video description so you can go there. Okay, so now let's go ahead and run our regression analysis. I've already imported the data into my version of Stata. I'm still on version 14, but it's not going to make any meaningful difference in how we perform the analysis. So you'll notice that I've got these variables over here. We're going to be essentially running a linear regression predicting student achievement from performance goals, mastery goals, and interest right here. So I'm going to go ahead and open up a do file editor by clicking on the icon right here. And next I'm going to use the regress command. So we'll type in regress, the name of the dependent variable, which is achieve, and then the names of the predictors as they appear in the data set. So we have mastery, interest, and then we have our performance goal variable, which is spelled this way. So if I just highlight this and run this, it's going to get me the standard regression results. And looking at our output, you can see we have our R-square value. It's 0.4044, which we would interpret to mean that the predictors are accounting for about 40% of the variation in achievement. The F-test is indicating statistical significance right here, so we would infer that the population R-square is greater than 0. And then when we look at our results below, we have our regression coefficients that are given. So these right here would reflect the regression slopes for mastery goals, interest, and performance goals, and then we have the intercept that's given at the bottom. This next column contains the standard errors, and this is where the problem of heteroskedasticity will have its impact. So if we have any kind of heteroskedasticity in our residuals, then that can either bias our standard errors upward or downward depending on the nature of the violation, and then that can ultimately have an impact on our t values that are computed. So t is just computed as a ratio of the coefficients to the standard errors. So again, if there's any bias in the standard errors, then that bias would be carried over into the t values and also the p values that are printed out, as well as the confidence intervals that are given for each regression coefficient. So to deal with this potential problem, we can request heteroskedasticity consistent standard errors. So I'll open up the do file again and go back to where we were before. So we had our regress achieve, again achieve is our DV, and mastery, interest, and performance goals are our independent variables. After performance goals, I'm going to type a comma, and now we're going to use the VCE option. So inside parenthesis we will type in HC3 and in parenthesis here, and that's basically a type of estimator heteroskedasticity-consistent estimator for the standard error, and that's actually the one that is one of the two that's endorsed in that article I was telling you about. There's actually, you could request HC2, but we're going to stick with the one that was endorsed in that article. So I'm going to highlight this and click on execute, run. And so now, as we're looking at our output, the regression coefficients are going to be exactly the same as they were above, but now we have our column of robust HC3 standard errors. And so this should address any problem that might be present with respect to heteroskedasticity. The t-values then now will reflect the adjustment to those standard errors, as well as the p-values and the confidence intervals. So really briefly, just kind of looking at this, the regression slope for mastery and interest, both of those are positive, and you can see that both are statistically significant at the conventional 0.05 level. And then performance goals, there's a negative regression slope, and you can see that now it is actually non-significant. So there's the p-value that's given right here. And this kind of highlights actually something or how the use of these different standard errors can impact inference. Previously, when we were looking at performance goals, there's our regression slope. Again, these are going to be the same, but the standard errors are different between those that are assuming homoskedasticity above and those that are assuming heteroskedasticity, but with the adjustment down here. So you can see that the p-value above previously was 0.036, which would have indicated statistical significance for the performance goal variable, whereas here we have non-significance for that particular variable. Okay, so that pretty well wraps up this video presentation, and I appreciate you watching.